I'm back from Thanksgiving break. I hope everybody had a nice break. I did. It was a nice little rest. Lots more sleep. I needed sleep. So let's look at our do now problems that we had today. We're starting a new unit today, Unit 2. We're talking about the probability and systems of equations. And I had you answer these questions just to the best of your knowledge. We haven't talked about these things, so we'll talk about some of them now. So in your own words, what does probability measure? Does anybody want to share? Michael?
Chance that something might happen.
The chance that something might happen. Yes.
Like the percent, like.
Could be a percentage. Yes. Erica?
The chance of a specified outcome occurring, usually represented as a percent, a fraction, or as a ratio.
Okay. Yes. That's like textbook definition right there. Very good. Yeah, you
I
guys
heard
are.
something with outcome from what she said. So I just put the probability measuring the outcome of one or more numbers or what it could possibly be. So I heard everything pretty much sounds the same.
Yeah, you guys are all saying that perfectly. So when we're talking about probability, I'll give you the definition that I have for your notes, but each one of you gave me a perfect definition as well. Basically, probability measures how likely an event is to occur. Probability is normally expressed or written as a fraction, a decimal, or a percentage, or a ratio. As a fraction, decimal, or percentage. Okay, perfect. Now, number 2. This one, I would be very impressed if y'all knew the answer to this since we haven't talked about it. And I think not some of us, people in general struggle with the difference between dependent and independent. So let's talk about these. So I had you choose true or false. First one says a coin flip and a dice roll are dependent events.
False.
Some say true, some say false.
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 Does anybody want to tell me why they chose that answer they did?
But there's two sides to a coin.
Okay, so you said true or false?
I said false.
False, because there's two sides of a coin. Okay, Erica?
They're not dependent events because they don't depend on anything else for their outcome.
They don't depend on anything else for their outcome. So what is falling into that anything else category whenever you say that? They don't depend on anything else.
Independent, it stands alone.
Okay.
Yeah.
It depends on something else.
Yeah, these are two standalone events. If I flip a coin and I roll a dice, if I get heads on my coin, does that mean I'm more likely to roll a certain number?
No.
No, they do not affect each other. Those are independent events. Whenever events are dependent, they depend on each other. It means that if one thing happens, it will affect the outcome of the other. So to answer the first one, a coin flip and a dice roll are dependent events. That is false. That is false. We would say that these are independent events, and we'll go into much more detail here in a moment when we get to notes. So now let's talk about the second one. And don't mind the highlight. I wrote this on yellow paper. This is like my original copy, and I used whiteout and tried to color it in so it wouldn't show up when I copied it, and I think I made it worse. So choosing a card from a deck of cards and then choosing another card from the same deck, but without replacing the first card chosen. are independent events. True or false?
True.
True.
False.
False.
Ooh. Why are we thinking true or false?
I'm thinking.
Someone raise your hand and tell me your explanation. Michael.
Because the outcome is different out of that one card's been taken out of the deck.
Okay, so what is taking that card out of the deck due to the second outcome?
Can't choose that card again.
Yeah, you can't choose that card again. So whenever I say without replacing the first card chosen, let's think about it. If I have a deck of 52 cards, okay, and there are 4 of each type of card, like there's 4 aces because of the different suits, there's 4 queens, 4 jacks. If I wanted to know the probability of choosing an ace, the first time I pull the card out, it's going to be 4 out of 52. That's my chances. I have 4 chances out of 52 options to get an ace. But once I take that first card out, my second card probability of picking an ace is not going to stay 4 out of 52. Now it's going to be 3 out of 51. There's 1 less card, 1 less ace. So we'll talk more about that later on, but let's answer that question now. Do they depend on each other or not?
I see they do.
Yes, sir.
I think it's true.
These are dependent. So they're not independent. Both of these are actually false. That second card being drawn, the probability of picking a certain card does depend on what card you picked the first time, if you're not putting it back. Now let me ask you this. Would these 2 cards being pulled become independent events, meaning they don't affect each other, if I did replace the card?
Yeah.
Yes, they would be. They would be. And if you're still a little confused, don't worry. We're going to go into detail later on. Yes,
Your screen has a little bit of lag.
a little bit of lag. Yeah, it does have a little, but not a whole lot I can do about it. If I could fix it, I would. All right. Any questions about number 2? Okay, let's look at number 3. Here's a little introduction to finding the actual probability of something happening. And we will go into more depth later. This is just an introduction. I wanted to see if anyone did know how to do this already. So a bag contains 3 red blocks and 2 blue blocks. If you draw 1 block and replace it, then draw another, what's the probability of drawing 2 blue blocks? Erica?
So the chances of drawing 1 blue block is 2 out of 5 or 40%. To
Okay.
calculate the chance of drawing 2, you then take your 40% and you divide it by 5, and then you take that answer, which is 8, and then you multiply it by 2.
Okay,
So
so
what's the
what
answer?
did you get?
16%.
16%.
It's a much easier way to do that.
Tell me, please.
Just take the 2 numbers that are there, look, that's 2 sets of numbers, so you're drawing 2 blocks. And you have 5 blocks to start with, you just times those 2 numbers.
Okay.
5 times 1.
Why didn't you check?
Can you tell us this one?
Yes.
Thank you. So 5 times 2, then 5
So
times 2.
first of all,
Drawing 2
these
blocks,
2
times 2
events, because
Five
we
blocks, 5 times
replaced
5.
the first block, these are independent. They're not going to affect the outcome. So we'll learn a formula here in just a minute. But basically, if the 2 events are independent, the way to find the total probability of both occurring is first we would find the probability of picking out 1 blue block. There's 5 blocks total, because 3 red and 2 blue. So we're going to put the total number on bottom. And on top, we're going to put how likely it is to get that blue block. There's 2 blocks out of the total 5. Okay, so that's the likelihood of picking a blue block first. Then we put that back and we do it again. For the second drawing, there's still 5 blocks since we put it back, and there's still 2 blue blocks. So both probabilities are 2/5. And to figure out what's the probability of these both happening, we multiply. So all we do is 2/5 times 2/5, and we just multiply across. What's 2 times 2? 4. What's 5 times 5? 25. So that would be our answer. C, 4/25 or 16%. That's the probability.
A lot easier than the method I was
Because
taught.
of only you replace the block.
Right. When we replace, if we didn't replace the block, the answer would be different, but we did replace it. And again, if you're still feeling a little unsure about this, this is our introduction. We're going to go in detail in just a moment. So that's number 3. Now let's look to the other page. The other side. Number 4. If a spinner like this is divided into 4 equal sections labeled A, B, C, and D, what is the probability of spinning A 2 times in a row? Does anybody have any ideas for how they might figure that out?
1/4 times 1/4.
2/4? Okay. Any other ideas?
I used the same method I did with the other one and came out with 6.25%.
Okay, so about 6.25%. Any other answers?
That's what I got.
6.25. Okay, well, I'm going to show you how to do it, and we're going to do it together again. So first of all, when I spin my spinner the first time, and then I spin it the second time, do those spins affect each other? Are they dependent, or is it independent?
Can't it depend on where it left off the first time?
Well, I guess it could, but then if we started really thinking about it, it could also depend on how fast you spin it, how long, we're thinking just the likelihood of any of these 4. So like if I spun and it landed on A, does that mean I can't get A again? No, so it'll still be the same likelihood no matter what. So the first time that we spin it, we have 4 options, so that goes on the bottom. And how many possibilities are there of getting A the first time out of 4? 1. One of the 4 options is A, so the probability the first time is 1/4. We want to know spinning it 2 times in a row, so the second time we still have a 1/4 chance of getting A. So we have 1/4 times 1/4. We'll multiply across. 1 times 1 is 1. 4 times 4 is 16. So 1/16 would be our answer. And if we put that into our calculator, we could find the decimal and the percentage too. 1 divided by 16 equals that there. 0.0625. Does anybody know how to turn this into a percentage?
Move the decimal place.
You just take your decimal and you move it 1, 2, right here. So 0.0625 is the same as 6.25%. So there's only a 6.25% chance that we'll spin A twice in a row. Kind of cool that we can do that. You can use this for anything. Probability is something I always found really, really interesting. So here's our little introduction into probability. And we're going to start some notes. Does anybody need this? Anybody need anything we just did? Okay. So this is the beginning of Unit 2. So I'm going to title my page Algebra 2. And we are in Unit 2. Do now was page 1 and 2 of my notes. I'll call this page 3.
That's fine. It's
Just check your math inside of your, square root.
Okay.
You shouldn't be getting a negative.
You don't want.
Okay, and this is day 19 completed. So you're fine. Okay, and we're gonna title this page probability. This is what we're talking about today, probability. And I'm hoping that today will feel like a little bit of a break for us. It won't be as many complex equations.
I like that better.
Yes,
Me
most of
No,
us
I like
do.
the complex equations.
Oh, well, don't worry, they'll come back. They'll come back.
Never land.
Probability. So, we're gonna start. What? I don't know what that is.
Yeah.
Somebody rolling something upstairs.
Sounds like a jam.
So we're gonna start by just writing the definition of probability so we have it in our notes. I know we did it on the do now, but writing it again won't hurt you. It'll just stick it in your brain better. So I'm gonna say probability measures how likely an event is to occur underneath in parentheses. I'm gonna write fraction, decimal, percentage. That's how your probability should be written, as a fraction, decimal, percentage. Once we've all got that written down, I'm gonna give you an example to keep in your notes. For example, if a six-sided die is rolled, does everyone know what a die is, or a set of dice? The cube that has six sides and every side has a different number on it. So if a six-sided die is rolled, the probability for example, is, here's our example, and I'm going to write out our probability. So here's the way that we notate our probability problems. Yes?
One thing that you might find interesting is on paper, if you want to specify the type and number of dice that are being rolled, you would put, say, 1d6 for one six-sided die.
Mm-hmm. Okay, so I write D6. So
1d6.
A D6 dice, or die. So strange, the
Technically it's die, but everyone says dice.
What type of math is this?
algebra 2. We're just talking about probability. This is important. It's important. So let's talk about this. This is how we notate probability. I would say P for probability, and in parentheses, we're going to write the event that we're finding the probability for. And in this case, the event is rolling a 4. So the probability of rolling a 4 is And then I'm gonna write a fraction. What would I be putting as the numbers in my fraction? Yeah.
6 would be on the bottom.
Yes, 6 would be on the bottom since there's 6 possible answers that I could land on with my die.
1,
Yeah, and why would we put 1 on top?
there's only 1 4.
Yes, we would say the probability of rolling a 4 is 1/6 because on a 6-sided die, there is only one number 4. There's only one of each number, 1, 2, 3, 4, 5, 6. So any number, you're going to have a 1/6 probability. Let's also write it as a decimal and as a percent. So to go from a fraction to a decimal, you just type that in your calculator, 1 divided by 6. And our decimal is 0.16 repeating. So I'll write 0.16. And to show that a decimal is repeating, we draw a line over it like this, just over the 6. That just means the 6's go on and on and on and on. And finally, let's make that a percentage. What percent did we put this as?
166.
1.66?
16.
Almost. One more place over. Yes, 16. We have to go over 2 decimal places. Or what you could do in your calculator is take it, I believe it's times 10. Oh, no, it would be times 100, wouldn't it? Yeah, we got to take that number times 100. So, and that gets us to 16.6 repeating percent. Or I would just take 16%. I'll tell you if I want you to put a certain decimal point. So there's our first example of a simple probability problem, just one event that we're looking at. And then we're going to make a little chart to talk about the 2 different types of events or whenever we want to find the probability of more than one event occurring. So I am going to draw a line here. I'm going to split the bottom half of my page in 2. Inches. Splitting this down the middle so that we can talk about 2 different things. And on the first section over here, I want you to write independent. Other side will write dependent events. And does anyone still need this example up here for the dice problem? I'm gonna move this. So, independent events are events that don't affect each other. So let's write that down. Means they happen separately. One outcome does not make the other change. So do not affect each other. Dependent events do affect each other. The probability. So I'm going to say that there are two events that we're talking about, and maybe the events are flipping a coin and rolling a die. We're going to call the events A and B. So if two events A and B independent, the probability of both occurring I'm going to give you a formula. We're going to use that same P parentheses. In your parentheses, we're going to say the probability of A and B. Just like we did in the examples in the do now, all we do is take the probability of A times the probability of B. The examples for this too, but I'll give you guys a minute to write. I'm giving you lots of writing today.
You hold pencil, stings fall in it.
Yes, I have that too, but it's on this hand.
Well, this is funny, and I hold it right here, that's the only way I can actually write.
Right.
Well, that's not true.
That's how mine is.
It has to be 4 areas of it. So the fingers are different. I'm sitting at the bottom.
Okay, here is an example, just like I talked about with the coin and the die. If you flip a coin and roll a die,
Dice.
yeah, like a six-sided, like a cube with the dots on it, a dice, like for playing cards and stuff.
Oh, okay, so a die is
A die is the singular of dice. So most people, even if you just have one die,
Oh.
most people will say, "Look, here's my dice."
Okay.
But
Okay, sorry, I didn't even know
no,
that.
no, you're okay. I'm glad you asked. I'm like, what is she talking about? So if you flip a coin and
Last year was the
roll a die or dice, if you prefer that.
I learned something new today.
Yeah. The probability, I'm going to abbreviate that as prob. We're going to write that word a lot. Probability of getting heads on the coin and rolling a 6 on the die is a whole lot of room. Try to fit all this on here. So first of all, the way that we'll write this is we'll put our P for probability and a parentheses, and we're trying to find up here P, A, and B. So A is our first event, and it looks like the first event would be heads, getting heads. What would our second event be? Bless you.
Rolling a 6.
Rolling a 6. Good. And we'll abbreviate it since we don't have a ton of room. So I'm going to write in my parentheses probability of heads and 6. Eight. Now we need to do the probability of event A times the probability of event B. Yes.
Probability will be 8.33%.
8.33. Let me double check. 8.33. Yep, you are correct. Wonderful. Okay, let's follow this together. So the probability of the first event of landing on heads on your coin, what would the probability of that be?
1 out of 2.
1 out of 2, 1/2, because there's 2 sides on a coin. One side has heads. So it'd be 1/2 times
1/6.
1/6. There's 6 sides on a die, and there's only one number 6 on there. So we would do 1/2 times 1/6. So 1 times 1 is
1.
1. 2 times 6 is 12. So the probability of landing on heads and rolling a 6 would be 1/12. And then we could do what Erica did and convert it to a decimal and a percentage as well. So I know 1 divided by 12 by typing it in my calculator is 0.083, repeating. Get it to a percentage. Remember, we just moved the decimal place over 2. 1, 2. And we're gonna, yes, 8.3. So it'll be 8.3%. So those are all the answers you could have. and let everybody get caught up writing that workout, and then we'll talk about the dependent events. Okay, now let's look at the dependent events, the ones that do affect the probability. Like whenever we pull a card out of a deck of cards and then we don't replace it, meaning that now there's one less option to choose from in the second round. So we're going to write a similar statement as the one for independent events. If two events, A and B, dependent, probability of both occurring is a different formula for this one. Probably need to write our example on the next page. I don't think I'm gonna have a formula.
Is this the formula that I was using?
I'm not sure. I would have to see the formula you use.
I could basically use unnecessary.
Literal
Second.
Right?
Today. Please.
The reason what you did, you've got the right answer.
So. Our chances for
Okay.
Shit. So if we look at what.
I'm just asking that day. I think that
We have 2 out of 5.
Yeah,
But it has this first one.
yes.
it is, and then it's a month break, so.
I'm not sure, but what he did worked. I'll have to look and see if I can figure that out because that's a really big deal. Okay, and then 1 cent, 25%, yes, and then. We'll go to. I put it in reverse order. What do you do? Yeah, it is.
Huh?
Interesting.
I'm just kidding.
Well, it works.
So that formula is not this one.
It's different. Yes, it is different, but that one is really cool and obviously it works. Okay, so here's how we would write the formula for the dependent events. We would say the probability of A and B occurring write a different formula this time. Equals. This time we'll write probability of A times probability of B given A. We'll tell you what that means once we get it written down. So that line in between B and A means given. So the new probability of B, given the fact that A has already occurred. That's what this means. So just like in the deck of 52 cards, where it starts off with a 4 out of 52 chance of drawing an ace. The probability of drawing an ace for the second event B is not going to be the same since we took one card away and did not put it back. So I'm going to label also what this means in case we forget and look back and are trying to remember. So I'm going to write it in a different color. Mm. Probability of B and A means. Probability of event B occurring given that event A has already occurred. Then I'm gonna write under here example on next page because we are gonna do an example on the next page. Everyone a moment, put that button down. And we'll do some practice together with these. Okay. So I'm gonna title a new page. I'll leave that up there as I'm titling, just in case. Day 19 continued. Okay. Dependent events example. Say if a deck of 52 cards is shuffled and you draw 2 cards. Does everyone know what we mean by drawing a card? Like, not like we're drawing a picture of it.
Taking one from the deck.
Yes, you're just taking one from the deck. Like, when you draw 2 cards without replacement, without putting the cards back after you pick them. I want to know, what is the probability of drawing 2 aces? So remember, just like we wrote in that little chart on the previous page, if we want to find the probability of two events, A and B, I'm just going to rewrite that formula. And they're dependent on each other, which in this case, these two events are dependent. The first card I draw is not going to have the same probability as the second card since we lose one card in between draws. So the probability of A and B equals the probability of A times the probability of B, given the fact that A has already occurred. Say that A is drawing the first A. And then here that B is drawing the second ace. So, okay, so first of all, what is the probability of A of drawing the ace the first time? How do we know that?
How many aces is in a deck?
Yes, how many aces is in a deck? There's 4, by the way.
Yeah, four.
So
So 4 out of 52.
4 out of 52 cards. So the probability is 4 out of 52. Now, this isn't our final answer because we're trying to find the probability of A and B. So we don't necessarily need to simplify just yet, but you could. What would this be simplified? Anybody know?
Mhm.
13.
What is it?
1 out of 13.
1 out of 13. Let's see. Yeah, you're right. It would be 1 out of 13. Let me see something. Quick pause on this problem. Would you guys like to learn how to type fractions on these calculators? Oh,
There goes the screen.
happened?
It was Mitch. That one. So use the calculator. Some of it on that.
Well, come on. Okay, so here's the guide. On your calculator, here's how to type fractions. You're gonna hit the alpha button. It's green right here. First button you'll hit. And then you're gonna hit y equals. Then you're gonna hit enter. What? Hang on.
Wait,
I looked this up. Maybe I
It's
hope
also
it doesn't
lagging really bad, so
I
I have
hope
no
it
idea
doesn't
where what you
just work for mine.
Wait,
Alpha y equals enter. It works on this calculator, but not on these. Okay. Never mind, guys. I'm sorry. I'm gonna have to look up how to do it on this one. Because there is a way to do it, but I guess I didn't find the right
Can you do it on
thing.
these?
You can. I
The
just gotta
small one?
figure it out.
Can you do it?
You figured it out?
figured
It worked on
Yeah,
yours?
it's working.
Well,
What did
maybe
you
I
do?
just typed it wrong.
1,
Alpha
4.
y equals. Why is it sending me there?
Oh, it worked for me too.
Really?
Yeah. 1 was 13. Yeah, it worked for me too.
Well, I guess it just doesn't work for this one. Well, good thing nobody has it. Can you guys tell me, is anyone's not working? You're gonna hit alpha, right here, the green
Alpha.
button. Y equals is at the top left-hand corner, right under your screen.
But fraction.
Yeah, and then you're gonna see this little thing pop up that says fraction. Well, good. and then you just hit enter. Just those 3 buttons.
Which one do you
And
have?
you got a fraction.
That's
Because I know
awesome.
one of
It's
them.
number 2.
I know one of them wasn't working when I tried to do something with it too.
Yeah.
So
I bet
I
you
think
it's
I messed
this
one.
one. It could
Do
be.
you know how to fix my calculator?
Yes, Erica.
I just turned mine on and it says RAM cleared.
Interesting.
Just press clear.
Yeah, I guess just hit enter and or clear and it'll get rid of it. Yeah, let me know if anybody's calculator is not letting them type a fraction.
Answers from the calculator, that's the last person.
So anyway, once you do that, we've got
Yeah, no, you didn't break it.
alpha y equals enter. Then I can type in 4 out of 52. I'm going to type in 4. And then to go to the bottom box, we use the arrow keys. Arrow down, 52. Enter. And look at that. It simplifies it perfectly. No work needed. You just got to know those 3 steps. Alpha, Y, enter. So if you want, these are the calculators you're assigned to. You'll have it every time. I made a little sheet paper and taped it on the inside of my case. Not a bad idea to write little cheat things on there and put it on the inside of your calculator case. It's the one that you'll be using. So it's not like it'll get lost. And if anybody needs tape, I got tape up here.
Yeah. You want to start?
So anyway, there's that. Are we ready to do the rest of this? Rest of this problem? Does anybody's fraction not work?
Mine,
Yours doesn't work?
no.
Did you do it on the big calculator?
Yes, he's trying to help me now, it's still not
Huh.
working. His is working with mine.
So full disclosure, we got this pack of calculators from the Texas Instruments Company, I think. And they were advertised, we thought, as new. But we have found, or at least like whenever I was looking through them, some of them had like corrosion and markings, and we found out they're not new. So I think we're gonna be replacing them with actual new ones, because I've had a lot of issues with them. Not working.
It also.
So-
You guys pay a lot of money. for it.
Right, we did pay a lot. Yes, Erica.
On mine, it looks like someone tried to scratch out the PIN number.
Love that. So good.
She stuff.
Yeah, these aren't new. They at least do simple calculations, but some of the functions aren't working. So Mac, yours is not working.
No, ma'am.
Okay. If you would like to grab another number that's not being used and try it for the meantime, you're
Okay.
absolutely welcome to. But up to you.
Okay.
All right, let's finish this problem and then I'll send you guys the lunch. So we found the probability of A of drawing the first ace, and we said that it was 4 out of 52 or 1 out of 13. So now we need to find the probability of B occurring given the fact that A already occurred. So how would we find the probability of B given A?
52, then you simplify that.
Almost. Okay, so let's say that A does occur. That's what this means.
Okay.
A happened.
So it'll be 3 out of 51.
3 out of 51. Yes. So if I have 52 cards total and I take one card out of that 52, my total number is not 52 anymore. Now my total is 51. Since A already occurred, I took one of the aces out. Is there still 4 aces to be
No.
chosen?
No.
Now there's 3. So this would be the new probability.
So I think.
Yeah, just the bottom number, because the total does change. Now, this, I believe, is as simplified as we can go.
About to find out.
Yeah. So now,
Yeah.
oh, it can be simplified?
Yeah,
Ah,
117.
okay, thank you. Always good to check. So we have the probability of A and we have the probability of B given A. How do we find the probability of A and B now?
Multiply 130,
Which is-
117.
We're just gonna multiply these numbers, 113 times 117. So probability of A and B equals
So,
113 times 117 equals, and all you're doing when you multiply fractions is multiplying straight across. 1 times 1 is
1,
1. 13 times 17 is
221.
221.
And only I knew how to break it down to a fraction. Right. I mean, to a decimal.
And this is your answer. Anybody know how to make that a decimal?
I just put 1 divided by 221.
Yes, all you have to do is remember a fraction is just a division problem written out and not solved. 1 divided by 221. That's all this means. So let's type that in. 1 divided by 221 equals,
0.004.
yes. So as a decimal, it's 0.0045. And bless you. What would it be as a percentage?
0.45%.
Yes, you just move the decimal over 2 places and it becomes 0.45%. So not even a 1% chance of drawing an ace 2 times in a row. Pretty small percentage.
Also realize how many plates are in the
Yes. 52 of them. All right. So there's your 2 first examples of probability of the independent and dependent events. We'll talk a little more about this after lunch. We'll get your exit ticket going and we'll have a little plan ready for what we're going to kind of do for the rest of the week. So y'all are free for lunch. I'll see you afterwards at 12:35. So let's do some practice. And we're going to look at independent events for this practice part, but I'm going to title my page first. And this is page 5.
Sorry.
You're okay.
And it's still not sharpened. Sorry.
No, take your time. It's necessary. I'm still writing my title anyway. Okay. So let's look at some examples. Independent events. And for the following problems, we're going to be referring to the same 2 items. We're going to be referring to a 2-sided coin where one side is heads, one side is tails. And we're going to be talking about a die again. Yes, Erica.
You could also notate a 2-sided coin as a 1v2.
Oh, I guess I could, couldn't I? That would be an interesting die. I don't know how that would look. Does it exist?
Imagine it would be the same as a 4-sided die, except for you'd have 2 1s and 2 2s.
Makes sense. That would make sense. Good way to put it then. So then we're gonna do what did I say? Yeah, a 6-sided die. Where each side is a number 1 through 6. You can have 1, 2, 3, 4, 5, or 6.
There's a 4-sided.
I guess it wouldn't technically be a cube. It'd be a shape of die.
Like a pyramid with 3
It's a
sides.
pyramid.
Yeah, some sort of pyramid type thing.
Like
Or
rolling
looks
in
like.
a roll.
Yeah.
I don't know. Okay,
I
so
know they have those
it
really big
D3?
multi-sided ones
Uh-huh.
that have a whole bunch.
yes. Well, if you played Dungeons and Dragons, you know that there are lots of different kinds of dice, not just the 6-sided
Mhm.
dice.
Mhm.
There's even the craziest one that I normally see is the D20, where it's a dice that has 20 sides on it. Pretty cool. It's pretty cool. I know. Well, Erica said
Yeah,
she might be bringing that in tomorrow, so we can all look at it. Maybe we could do some probability with the D20.
And Black set's
D100
got
is
a
the
bunch of irregular die too.
Oh yes, yes. You were showing me those. I love those.
D100s.
Oh yeah.
So D100
Yeah.
exists.
Yep.
They're
Dang.
wild looking.
They're
crazy.
I can't even
They look
imagine.
strange.
Looks like a golf ball almost.
Yeah.
Yeah, that makes
Very
sense.
similar.
Like a golf ball.
How do you see the numbers if they're extremely tiny?
Very
The
carefully.
dice is like this big.
Oh,
So you gotta
Yes.
see like
D100
what's the one in the
Yeah, it's
middle.
not like a time. It's huge. It's big.
They're huge.
Must have
It's
to
like
be.
It's like rolling a softball.
That's funny.
Like,
Okay, so the first problem
Yeah.
is to find the probability of not rolling, let's do the flip first. Of landing on heads rolling an even number. Yeah, 1 through 6 are our options. So we need to think about this. Probability of landing on heads and rolling an even number. So remember, I'm telling you already that these are independent events, but we know that these are independent because whether I land on heads or tails, that's not going to affect the likelihood of what number my die is going to land on. They have nothing to do with each other, other than we're doing them at the same time or consecutively. So, first of all, we need to figure out what the probability of each event is. So let's make sure we remember how to notate that. We're always going to start with the letter P, and in parentheses, we're going to give the event a name. You could use A and B. You could literally write out heads and even number. I think maybe for this one, we'll use H for landing on heads. And we'll use E for even number. So the probability of both of these.
What's the big 50%? Half of both ones you got.
The probability of landing on heads would be 50%, yes.
But the probability of rolling an even number would still be 50% because half the numbers are even.
So we'll see what happens when we put those together. We'll see. So in our notes, we talked about independent events. There's a formula we use to find the probability of A and B. We find the probability of A, and we find the probability of B, and we just multiply them together. So instead of A and B, we've got H and E. So first, let's find the probability of landing on heads. 1/2. There's only 2 possibilities, heads or tails. One of those possibilities is heads. So 1/2. Next, we need to find the probability of getting an even number.
3 over 6.
3 over 6. So does everyone understand how there's 3 possible ways to get an even number on the die?
Yes, because there's 3 even numbers.
Yes, our even numbers are 2, 4, and 6. There's 3 of them out of 6 total options. So 3 out of 6 or 1/2. Exactly.
So 25%.
Let's see. Now we need to do the probability of these times each other. So I'm going to write that formula out again. The probability of landing on heads and rolling an even number would be the probability of landing on heads times the probability of rolling an even number. So now we just plug those values in. 1/2 times 1/2 equals 2/4. 1 times 1 is 1.
That's 1/4. So if you did them separately, it'd be 50%, but I
2
It's
times
25.
2 is 4. So we've got 1/4. So very close. Or 25%. Exactly.
So
So-
if you did them by themselves, it'd be 50%. If you
Yes.
just did the rolls or but when together, it's 25%.
Yes, exactly. It's the probability of landing on both. So we could get our decimal by taking 1 divided by 4. Yes, Erica?
So this formula works for if we want to stretch this out to whatever number of events we want.
Yes, as long as they are independent events. As long as they're independent, this will always work. You could use it for anything. So we got 1/4 is the probability, or 0.25 is the decimal, or what's the percent?
25.
25%. You just move it over 2 decimal places, 25%. So there's a 25% chance that will land on heads and roll an even number. Kind of cool. Kind of cool.
So what it's saying was true that both of them would basically be 50%, but if you
Yes.
put them together,
Yes.
it's 25.
Exactly. Exactly. So I'm going to give you a couple more of these scenarios, and I'm going to have you guys try some on your own. Okay? I'm going to come up with some here real quick. Let's see. Remember, these are the events. I'll underline them. So for example, rolling a 5 or a 6. Is anyone confused about how you would find the probability of rolling a 5 or a 6?
Are we still using the dice of 6 up there?
Yes, yes. We're going to be using the same 2-sided coin and a 6-sided die.
So 2 out of 6?
Yes, 2 out of 6. There's 6 numbers, and 2 of them are 5 and 6.
Wouldn't that be 1/3 reduced?
It would be 1/3 reduced, yes. So we're going to find the probability of landing on tails and rolling a 5 or a 6. I'll give you 2 more to try on your own.
So geometry, actually, a lot of the problems take a lot just to be able to solve.
Yes.
And when we're doing these, do we have to have the fraction, the percentage, and the decimal, or does it matter which one?
So typically I'll tell you what form I want you to put it in. For these practice examples, I do want you to do all 3, just so we can get used to converting and make sure we're all comfortable with knowing that all 3 are the same. So for today, I appreciate you asking that. Let's try to write our answer in all 3 forms.
What is it saying in the report part?
Under which part?
We can't see, well, I can't see the words if you just push it up, the recording.
Or,
On
oh,
the screen.
my bad. There you go.
Thank you.
Of course. So here are some problems. I want you guys to try these on your own. I'm gonna set about a 10-minute timer here, and then we'll go over them together, see how we did. I'll pause the recording. Okay, guys, let's look at these problems. Whew. So, let's start with number 2. And in all of these problems, we're using the same events. Well, not the same events, but the same items to determine the events. We've got a 2-sided coin, one side heads, one side tails. We've got a 6-sided die with the numbers 1, 2, 3, 4, 5, and 6 on each side. So let's look at number 2. How are we going to solve number 2? What should we do first?
Tail.
Is landing on tails?
Yeah, let's
Right.
first find the probability of landing on tails. And how would we find that?
It's 2-sided coin, so you only can lay on tails on one side, so 1 out of 2.
Perfect. It's a 2-sided coin, so that means there's 2 possibilities. We put that on the bottom. And on top, we say, how many times could you land on tails out of the 2? There is 1 tails, 1 heads. So the possibility of landing on tails is 1/2, or 1/2. So there's the first part. Now, how do we find the probability of the next event, rolling a 5 or a 6?
Same way, 1
over 6.
2/6. How do we know that 2 was the number on top?
Because it says 5 or 6. So
Yes.
that's 2 numbers.
So on a 6-sided die, there are 6 possible outcomes. We could either get 1, 2, 3, 4, 5, or 6. And then I wanted to know what's the probability of rolling the specific numbers, 5 or 6. So that's 2 total options out of the 6 possible. So 2/6. Okay, what do I do with these 2 numbers?
Times them.
Yes, we multiply. So let's multiply straight across. What's 1 times 2? 2. What's 2 times 6?
Well,
Well, we could simplify this to
1/6.
1/6. So there's our fraction answer. How do we find our decimal?
1 divided by 6.
Good. 1 divided by 6. And I got 0.16 repeating. So remember the line above that 6 shows that the 6 is repeating. It keeps on going. So there's our decimal answer. And what would our percentage answer be?
16.
Good. 16.6 repeating.
That's 2 points over to find.
Yes, all we did to find that is we took our decimal and went over 1 space, 2 spaces, and then I had 16.6 repeating. Yes.
Would we get marked off if we did 0.6?
No, because I didn't tell you to. In this case, whenever it comes to marking points off for rounding specifics, for instance, if you got 16, I know you did the work properly. Now, if I tell you that I'm specifically grading you on rounding to a certain point or a certain number, then points would be taken off, but I'll always give you a heads up for that. Good question. Okay. Did you guys get that one?
Yes.
Okay. Any comments, concerns, questions about number 2? Okay, let's look at 3 then. How do we solve number 3?
The same way you saw it.
Pretty much the exact same way. We're not going to use the same numbers though for the second event. The probability of landing on tails is what?
1/2.
1/2 times. What's the probability of rolling a number that's bigger than 1?
5/6.
5/6. Out of the 6 total numbers, 5 of them are bigger than 1. 2, 3, 4, 5, and 6. So we're going to multiply 1/2 times 5/6. 1 times 5.
5,
5. What's 2 times 6?
12.
12. 5/12. Is that simplified?
No. Wait, yes.
Yes. 5 and 12, we can't fit anything inside of them. So that's the fraction. How do we find the decimal?
Divide 5 by, I mean,
Yeah.
12, 5. Yeah, that.
Yes, we're going to take 5 and divide it by 12. And that's going to give us 0.416 repeating. 0. Here, that here, so you can kind of see what my number was. 0.416 repeating. That's my decimal. And what's my percentage?
41.6.
Good. Just move it over 1, 2 spots, and we'll get 41.6%. Beautiful. Anything we want to talk about for number 3? Any questions? Comments?
I don't know how, but at first I got 60%. I don't know, maybe I just did something wrong on accident or what.
So hang on, because I looked at that one, right? Or are
Yeah.
you thinking of number 4?
No, we did number 3 together.
Okay,
Still got
so
50%.
what number did you get?
I think I
You
might.
had 5/12, right?
Yeah.
Okay, that's what I thought.
I don't know.
So I wonder if maybe it just got typed in wrong.
Maybe
I don't know.
because I just did it.
I
with
could
my
have
calculator
checked it
again, and I
actually
was
when I was
huh.
over there. I just saw the 5/12. And I was
Yeah.
like, "Oh, that's right. So 60% must be. I should have known that. Well, that is my bad. Let's see. How did you get 60%?
I have no clue.
I'm curious.
I don't even remember.
See what 7/12 is. Even that's I really don't know. I'm at a loss. Well, you figure it out. Let me know because I'm kind of curious.
Okay.
Okay. Any other questions, comments? Number 3.
I think I know how she got that.
How?
She added the 2 to the 6 when she was putting it into the calculator.
Maybe.
Oh,
Let's
yeah,
see.
I think
So
I might have did that on it.
5 out of 8. Well, does give you 62.
I don't know what's going on right now.
Pretty close. That's all right. That's all right. We don't need it. Okay. Are we ready for number 4?
Yes.
Yeah.
Okay. What's the probability of landing on heads?
1/2.
1/2 times. What's the
4/6.
probability of rolling a number smaller than 5? 4/6. Is anyone confused about how we got that? Tell me.
I almost got confused because I was going to use 5 at
Ah.
1. So if you said smaller.
Yes, you are not the only one who did that.
I had
So-
the same brain fart.
Yes, whenever we look here, we have a number smaller than 5. So remember, our options are 1, 2, 3, 4, 5, and 6. 6 is not smaller than 5, so that's being ruled out. 5 is 5. It's not smaller than 5. That's being ruled out. There's only 1, 2, 3, 4 possible outcomes that are going to give us a number smaller than 5.
4 out of 6.
So 4 out of 6 total possibilities. Absolutely. So we're taking 1/2 times 4/6. Yes, we could also simplify that to 2/3, or we could simplify after we multiply. Either one will work. What's 1 times 4?
4.
4. 6 times 2?
12.
12. And let's simplify that.
1/3.
1/3. Man. Okay. That's our fraction.
.3333.
This is our decimal, 0.3 repeating.
Yes.
And what's our percentage?
33.3.
Good, 33.3 repeating percent. Awesome, guys. That is so good. So good.
Well, independent is easy. Let's see if
Independent. Good. The independent's not so bad. Now, the dependent, in terms of math, it's no harder. You're still going to be multiplying two fractions. That's it. The only thing is the second fraction might take a little more thought to figure out. So,
Why do you put the line over this thing?
good question. Why do I have lines over like the 3 and the 6 and the
It's
6?
repeating.
Did someone answer that?
It's
Repeating?
repeating.
Okay, yeah. So look, I'll show you, Ella. Whenever I type in 1 divided by 3, I'm going to get 0.33333333. The calculator doesn't show it, but these 3's continue on for infinity. They go on forever. So when we have a repeating decimal, is what we call that, instead of writing out a million 3's, we just write the first 3 and we put a line over it. That shows that 3 repeats. Yeah. Uh-huh.
I forget why you prefer the line to the squiggle.
The line to the squiggle on what?
When you demonstrate that something is repeating, because you can also do it as the sideways S squiggle after the number.
Oh, I don't think I've ever seen it that way.
Oh.
Yeah, I
I don't know. New to me. Could be totally a thing. I'll have to look into that and double check. But the reason I don't do it with squiggles is because I didn't know it existed. So there's your answer. Okay, guys. Anybody still need this? Can I move it?
Yes, ma'am.
Okay.
Okay.
New page, starting page 6, and we're gonna do some practice on the dependent events. Okay, so I'm gonna title this. Again, Algebra 2, Unit 2. Still on day 19. Can you believe that? We're on day 19 out of 30 days.
Yeah, it's almost over with.
Nuts. Absolutely nuts.
We got like 2 more tests before the end, or?
Pretty much. I'm planning on we're gonna try to get like some mini quizzes in before the end because the way that this class was set up, you guys are in a unique Algebra 2 class. It probably won't be like this next term, because we had some coming in that didn't have the Algebra 1B yet. And just it's a unique situation.
And we really
So-
appreciate you. 'Cause
Oh,
that was
well,
me.
I appreciate you guys. Y'all have been so patient with me, and this is my first time teaching Algebra 2, so we're all in this together. We are in it together. Okay, so now we have practice problems for dependent events. So I'm going to title that. And basically, whenever we're looking at dependent events, we're typically going to be working with problems where, like the big example we've been using is a deck of cards. You draw a card, you don't put it back.
Okay.
That means the next event, you're going to have one less option. Or it might be something like, I have a bag of marbles. I take a marble out, then I draw again, but I didn't put the original marble back. It's pretty much always going to be a one less type of problem. So as much as these are slightly more, what the word is I want to use, slightly more involved than independent events, it's not so bad once we really are able to understand what's happening. It's not so bad. So let's talk about, and I'm going to draw a picture for this one. I think that would be nice. Let's do a bag draw a little brown bag. Like this. And inside the bag, I have. Three
That's purple or blue?
purple.
That looks more blue.
Well, purple or blue. I just won't use both.
It's
Purple or blue.
It's a red blue.
It's a color.
Yeah.
It's some kind of color, I don't know.
Then 2 orange marbles.
That looks more of its color.
Yeah, sometimes you just need a comparison color.
Yeah.
Uh,
Oh, God. It's Monday, that's right. It's Monday.
1,
Shows.
2, 3, 4 green marbles.
This is what you just did 2, 3, 4.
Yeah, pretty much. Pretty much. So. Bless you. First, before we give you the multiple events, let's ask ourselves these questions. What is the probability of drawing an orange marble?
2 out of, I can't count, 9.
2 out of 9.
Okay, yeah, 1, 2 out of 3,
9.
4, 5, 6, 7, 8, 9. Yep, 2 out of 9 for the orange. What's the probability of drawing a green?
4 out of 9.
Yeah, 1, 2, 3, 4 out of 9. And then what's the probability of purple?
3 out of 9.
3 out of 9, or
1/3.
1/3. Beautiful.
I'm gonna draw this bag of marbles too.
Yeah, I'm
Do it.
the same thing.
Come on, draw
Draw
the marble. I don't know. I think pictures help. I really do, and they're more fun. Drawing numbers all day, you know. Sometimes you gotta mix it up.
Honestly, today I've drawn numbers.
Yes. Well, and a lot of 4-sided shapes. A
Well,
lot.
mostly it's been numbers because
Well, yeah. Now that you're doing that, lots of numbers.
I just did one whole period of numbers. Now I'm doing another whole period of numbers.
Yes. Okay, so we'll do a practice problem of dependent events together. Make sure we understand how to do the whole process, and then I'll give you some to do on your own. So this time we're going to be trying to figure out the probability of drawing 2 marbles of a particular color, one after another. And whenever I draw the first marble, when I take it out of the bag, I'm not putting it back in the bag.
With the pigeon, that's a G.
Yes.
Yeah.
So that's going to change the probability of the second event. The second marble I draw out is not going to have the same probability as the first. So let's say, I'll figure out how to word this. If I draw 2 marbles without replacement, meaning I don't put it back after I pick it, and W/O, that's short for without, in case you didn't know, and you're like, what is that? That just means without. So if I draw 2 marbles without replacement, what is the probability in 2 orange marbles? So getting orange, oh my gosh. I was saying marbles and writing orange at the same time. My brain. Right, oranges.
Yeah.
Drawing 2 orange marbles. I'll fix the E in a minute.
Let it dry.
Let it dry.
Oh, I see, lower.
Yes. So what is the possibility or probability of drawing 2 orange marbles? So we'll walk through this one together. Make sure we understand how to do it. So since these are, yes,
Are you pulling 2 marbles at the exact same time? Or
No.
one after the other?
you're 2 separate events. So just like, so whenever I say without replacement, that means that I'm taking one out, not putting it back, then drawing another one. Great question, because that probably would change the outcome. However, we're doing them one at a time. So let's look at our little formula back in our note. I said for dependent events, to find the probability of A and B, or drawing an orange, then drawing another orange, we need to find the probability first of drawing that first orange, and then we need to find the probability of drawing orange again now that we already took one out. So let's walk through this. First of all, what is the probability of drawing an orange marble the first time?
1 out of 9? No?
The first time. 2 out of 9. Right now there's 2 orange marbles to start. So out of the 9 marbles I could pick, when I stick my hand in, there's 2 marbles that could be orange in there.
I just erased it.
That's okay. So we're gonna first write, well, here, let's write out the equation. Sorry, I'm getting ahead of myself. Probability of first, I'm gonna write the probability of first orange and second orange, meaning drawing orange the first time and drawing orange the second time without replacing the first orange. Equals. Find the probability of the first
Okay.
things. Remember, this is where we do that probability of B given A. The probability of the second event happening, given the fact that that first orange one is already gone. So we're saying,
1 over 8?
Well,
I don't know yet. Let me see. Hang on. So yes, there'd be 1 orange left out of 8 marbles left. Yeah, exactly. So let's write that. Probability of B given A. Okay, so there's kind of our formula written out. So on the first turn, the probability of the first orange,
2 over 9?
yes, we found up here, there's 2 orange marbles out of 9 total marbles I could pick. So for the first orange, the probability is 2 over 9. Now for the second orange marble, we're looking at a scenario in which one of these marbles disappears. So let me see if I can, let me just, and this one is, okay. That marble disappeared. What's the possibility of getting an orange marble now?
4 out of 8?
1 orange is left, and there's 8 total marbles. Yes, 1 out of 8.
Wait.
I heard wait. Who's confused? Tell me.
I wasn't just looking up. I'm seeing, okay, the 9. I'm hearing 9 and I'm hearing 8.
Okay, so here, let's take a step back.
Yes.
The probability or the likelihood that I'm going to pick an orange marble the first time, there's 2 orange marbles out of a total 9 in this bag to start. So we know that we're gonna have 2 out of 9 for the first probability. Now, to find the probability of the second orange, given the fact that the first orange was picked, we're gonna pretend that first orange marble is gone, because it is. It happened in the first turn. So the probability of picking orange a second time, if we don't put that one back, now there's only 1 orange to pick out of a total 8 marbles left, since that one's gone. Does that make more sense?
Yes, it does.
Okay, good.
All
Thank
right.
you for asking, because I'm sure you weren't the only one.
Thank you.
So for the second orange, we've got 1 out of 8. So how do we find that total probability?
Times one.
The first orange times
Yes.
1/8.
Yes, that's all we're doing. We're just multiplying the two fractions, just like in the independent events. We're just gonna take,
The equation makes me think different. So
is it the given part that's throwing you off?
yeah. So
So
you
it
have to-
almost makes it look like you're doing another step here, but you're not. It's
Okay.
just the way that it's labeled. I'm not gonna make you write it this way. If that confuses you, don't use it.
Okay.
We can just use this, the second orange.
Okay.
This is just how they annotate it, kind of like the notation form of it.
Okay.
Not necessary though. As long as you're pulling out the correct numbers, I'm totally fine with that. So the probability of, I'm gonna say 2 orange. And again, these are very non-specific. Inside the parentheses, I'm just writing what makes sense to me. You might all have something different written, and that's also okay. So the probability of getting 2 orange, we took 2/9 times 1/8. Okay? 2 times 1 is 2. 9 times 8 is, you said 72?
Yes.
70.
1/36. You simplify it.
Or 1/, what is that?
36.
36. Awesome. 1/36. And what would our decimal and our percent be?
Your decimal is 0.27.
0.027.
Yeah.
Sorry.
Ah, yes, that's important. 0.027 repeating.
I said 0.027.
Oh, then you're good.
Say.
Perfect. So 0.027, and the 7 is repeating. Or
Percentage is 2.7.
yes, we move it 2 decimal places right to here, and we will get 2.7 repeating percent. Beautiful. So the difference here is that whenever you find your 2 fractions to multiply, the second fraction is going to be smaller. The denominator will be smaller, the bottom number.
So, what about the third one?
The third one.
3/9. Oh, yeah,
Okay, which one? What are you looking at?
the third, 3/9 or 1/3.
3 9s, 1
We got
3rd.
2 9s and 4 9s. We did okay with that, but we got 3 9s.
So how we got 2 9ths and 1/8? You know how we got that, right?
Yeah.
Okay. So then we multiplied the 2 numbers right here,
Mhm.
and we got 2/72,
Mm-hmm.
right? So are you to there?
Yeah.
Perfect. So then we simplified
1/36.
2/72, 1/36. Good. Then we took 1 divided by 36 on our calculator and got 0.027.
All right.
Repeating. The 7 is repeating.
All right.
So the difference between the independent event is it dealing with 2 separate events, and then you find the percentage or decimal point, and then the dependent one is 1 event broken. I don't like.
Well,
So-
it would be like if I was to flip a coin, I said the very first one has to be heads, or else I quit the game.
Ah.
That still doesn't make sense. I'm trying to.
So the
I
main
don't
difference
get it.
between independent and dependent, like we could be drawing bags of marbles and it could be an independent event if I put the marble back every time. Because if I pick an orange the first time around, but I put that orange marble back, my probability of picking an orange the second time
Will
is
still be the
gonna
same
still
as-
be, yes, that 2/9, because I still have 2 orange out of 9 total. The only thing that changes whenever we're working with dependent events is that whatever happens in the first event changes what could happen in the second event.
Cause I know when we was doing the independent one, we was using, heads or tails, and we was using dice.
Yes.
And we put them both together to figure out the
Yes.
percentage. On this one, we're using just marbles and then take
Yes.
away for the second part.
Yes.
Yeah.
No,
So it just depends on the scenario, because I'm trying to think of a dependent example where it's two separate things, like a dice and a coin. I might have to think about that. I'm not sure. But I'm usually gonna tell you which one we're doing.
Okay.
But we'll practice making sure we know how to identify more and more. Yes.
Real.
So if we can figure out the odds for the second part in our head, it's the same formula as for the
Yeah,
Yeah.
pretty much. It's the same thing. You're just finding two fractions and multiplying them every time.
I wonder if my formula would work for that.
If what would work?
The formula that I figured out would work for that.
It might. You'll have to try it and let me know. Okay, I'm gonna give you some problems. So, do
Using marbles.
yes,
Alright.
using the marbles.
Alright.
And we are not replacing the marbles, meaning
We're losing them.
we're always gonna lose
Okay.
one more if I tell you one more. If I tell you you're losing 2, you'll lose 2, and it'll change your numbers accordingly.
Losing our marbles.
Yes, we're leaving our marbles. I swear. So, what is the probability of drawing, let's see, an orange marble, then without putting the orange back in, drawing a green marble after? Okay, Mac, I feel like I just realized how to answer your question, and then I'll get you, Erica. So with independent events, I think that what you were saying is correct, that it's like two different things that are happening kind of at the same time. And they don't affect each other. With the dependent events, it's usually, or it's always, one event happens, then something else happens. So the ones that depend on each other, one has to happen first, and then something happens. The independent can happen at the same time. Like this cannot happen
Yeah.
at the same time.
One has to happen first in order
Yes.
to get the
That's never
second
cause
number.
or return effect.
Yes, absolutely. And then Erica.
We're resetting the bag between them, right?
Yes, you are resetting the bag from number 1 to number 2. So you've got 9 marbles again at the start of number 2. Good question. Okay, then I'll give you one more. The probability of drawing purple. Then see that okay?
Purple then orange.
Purple then orange, yes. Okay, I'm gonna pause this, give you a little time. All right. So, number 2, we wanted to find the probability of the orange happening So the probability of drawing an orange, and then we need to find the probability of picking out a green marble, given the fact that we already picked an orange marble. So I'm gonna say P green given orange. And again, if this notation confuses you, you don't have to write it this way. But what is the probability of picking an orange marble the first time?
2 out of 9.
2 out of 9. Okay. So now let's say we picked that orange marble. It's gone. What's our total marbles right now?
8.
8. So that's our new number on the bottom. The new total goes on the bottom. And how many green are left to
4.
choose from?
4.
4. There's still 4 green marbles in the bag. Even though we took an orange away, there's still 4. 4 green. So we've got 4 out of 8. So to find the probability, we're just going to multiply these two.
2 times 4 is 8.
2 times 4 is 8.
8 times 9 is 72.
8 over 72.
1 9. We simplify it.
Which is 1 over 9.
Decimal will be 0.111.
Good. 0.1 repeating.
Mm-hmm. Percentage is 11.1.
11.13%. Perfect. Okay. I know we're going over these a little bit fast. I just want to give you time for the exit ticket. I'm happy to go around and look at these while I give them to you. Okay, let's look at number 3 real fast. Purple and green. What's the probability of getting a purple marble the first time? Good. 3 out of 9 or 1/3. So I'm going to go ahead and simplify to 1/3 to save myself the simplifying later. And then what is the probability of getting an orange marble after I have picked out a purple?
1/4 if you simplify it.
Yeah, so 2 out of 8 or 1/4.
I didn't simplify mine at first. I simplified
And you totally don't have to.
I did not do that.
So 1 times 1 is 1.
6 over 7.
3 times 4 is 12.
Oh, okay. I guess I should have just did that.
So if you didn't do the work that way, let me show you what it would look like. We had 3 over 9 times, what was it, 2 over 8?
Yes.
2 over 8.
Give you 6 over 7.
Yes. 3 times 2 is 6. 9 times 8 is 72. And then we would need to simplify it, which would eventually get us to 1 over 12. Okay.
The decimal to that is 0.083.
0.083.
Do we always have to put the 0 in front of the point?
It's not a necessity. Like if you don't, I won't count you off. I just think sometimes it helps to see where the decimal is. I don't know. It's a personal preference,
Okay,
I
okay.
guess. I won't count you off for it. And what's our percentage?
8.3.
Good. 8.3. Repeating percent. Okay. I'm gonna give you an exit ticket. If you do not finish before you go, that is no big deal. It's not due until next Monday. Okay, we always have a week. And if you're not feeling confident about it today, talk to me. We can work on it a little together. Let me give you a problem. I'm gonna draw a picture for this one. Day 19 exit ticket. Ooh. Monday. December. I can't believe it's December. Great. December 9th. Next Monday. So I'm gonna say if there is, we're gonna use a bag of marbles again. We'll say 4 orange marbles. 5 green marbles and 1 purple marble. Okay. And they're all in a bag. So I'm just going to ask you, what is the probability bless you, a purple marble then an orange marble? And this is without replacement, meaning once I've drawn the purple marble, I don't put it back. So this is dependent. I'm gonna draw a little picture. I haven't worked this problem out yet, so I don't know if your answer is correct or not. If you finish, feel free to turn it in, and you are free to go. Just that one question. Have a good day.